Howdy folks, I'm Mark. I make stuff, and today we're going to be making a handy-dandy to-do application with TypeScript and Redux. Another to-do app? Yeah, to-do apps are basically how we teach React now. It's the law or something apparently, I don't know. Anyway, this isn't just any to-do app. We're going to be tricking it out with all kinds of useful features and some fun animations. And this is no paper-thin demo. We're going to be building it out completely and deeply because that is how we learn. First off, why Redux, you're probably asking? In use cases where global state updates frequently, Redux is very nice to have around. And with libraries like Redux Toolkit, I'll show you that those bad old days of Byzantine boilerplate are in the past, thankfully. Also, TypeScript. I really wanted to show this in TypeScript because, well, TypeScript is rad, and just like Redux, I think some people avoid it because it seems complex when it doesn't have to be. Are you ready? I know I am. Let's get started. Just like a cooking show, we're going to show you what the final dish will look like before we start baking it. We're going to enter in some items. I'm going to use the enter key here, but we can use the button if we wanted to. And we can go in and mark those as complete. And then we get that track down here. And we can actually give them tags. Right? And mow the lawn would have the same tag. This we call it, let's say, personal. And pick up cake is personal. We don't have to type it in, we already have it here. But let's say we want to also add something like urgent, because that's important. We can actually change the names, the titles here. So I'm going to say finish reading book. What book is it? We'll say what the name of the book is. And then we can go into our filters here and say, hide the completed items. So the mowing the lawn will go away. We can say, just show me the outdoor, and you can see just the ones with outdoor there. And we can also clear all the to-dos, and that will take care of that. But you'll notice too that if we get rid of the filters real quick, I'll show you something interesting. So if I refresh the page, all of it sticks around, and that is because we just store those in local storage as text, and then we parse it with a try-catch, and we're all set, right? It's a way to add easy persistence without having to stand up the infrastructure of an external database or a backend. And so that's how that works. We can delete them, obviously. Because it's the first thing people ask for, whenever you make anything for the web, it's almost like saying, if you make a device, people say, can it run Doom? If you make something for the web, they say, is there dark mode? And there is, and it's pretty easy. We're not going to get too into styling in this piece, but we're going to use Tailwind to manage this. It's using a class at the HTML level, and then Tailwind grabs onto that. We'll go over that later. We're going to walk through the commands you need to get started on an application like this. I'm not going to run through these in a terminal in real time because I honestly don't think that you want to sit through and watch me do that. But you know, we start by creating a simple create React app with a TypeScript template. We're going to install Tailwind pretty quickly, just with Tailwind CSS, post CSS, auto prefixer. We're going to run the Tailwind CSS init, which will create this config file. This config file is pretty blank when it starts up. We need to copy and paste this content item in here so that it will latch on to TypeScript files and JavaScript files. And for it to actually work, we need to copy these things into near the front of our index.css, right? So we're going to go ahead and get rid of, when you start a new application, there's a lot of stuff you can get rid of in a typical create React app application, right? Like your app.css, you can probably get rid of. We're just doing this on the index.css, right? And we're declaring a font and doing some other really simple foundational things, but really this is the big deal. And once that's set up, you can go into your app and add some very basic tailwindy kind of classes, and just to confirm that everything's working, right? So in this case, we just have a gray background that's very dark. And so when this loads, you'll know immediately that this is what it's supposed to be. Once we move on to getting Redux set up, we would install Redux, React Redux and Redux Toolkit. And we're going to start looking at our types. You can see we have some generic stuff down here like an object and an event, but our biggie right here is the brains of the operation, so to speak, is the type for the to-do item itself, right? Each is going to have a title. It's going to have an ID that's a unique string, date created, date completed, is complete, as well as a list of tags. And we're going to get to the tags later on as a feature where you can add and filter tags that allows a to-do to exist on multiple virtual lists, right? And then we have an action type. Most of our action payloads will be just strings, but sometimes we need something more complicated. Our dispatch type we're going to use in another spot. So once we have that started, we can go in and start on our slice. Now we have our state. This is the main thing. What we're doing here, we have a slice of state, not all of it. We're just using the to-do slice, which has all of our to-do information. And later on, we're going to add a separate slice just for dark mode because they are, theoretically, they're completely separate. And so they don't need to be together. Our to-do state is going to have our tags, which are derived from to-dos, our to-dos. And then we have these other items that are mostly about how we're going to handle UI later on. We're going to go through those, but those are just there so that we can use them later. We have our initial state, which to begin with might be something like that, right? So your tags and your to-dos, you start off, they're nothing, right? So eventually we'll get into why that's significant. And then the big part of this is we have our to-do slice, which is based on create slice. That function, it takes in the name, which is in this case is to do, our initial state, which we just went over, and the reducers. That's basically it. So if we just had one reducer, and on our other slice, we really only have one reducer, it's very, very simple. We go down to the bottom and we register these items, and we don't have to do action creators for these. Redux Toolkit kind of automates some of that for us. We just have to export them as actions, and then they'll become available to the components. We're going to create a store using bits of our slice. You can see that we're also including the dark mode slice. So we have two slices in our store, and we're exporting the dispatch, which we're going to use later on to dispatch our actions, right? And then we have our hooks, which are based on the file that we just created. And we have the root state and to-do dispatch that we're bringing in. Root state ends up being used in our selector. So the components end up consuming these two, use to do dispatch and use to do selector. And selector is what we're going to use to get information from state, and our dispatch is what we're going to use to send actions to our reducers. Once we have all that set up, we can go in and add our provider and wrap it around our app, and we'll use the store that we just created to provide to the store. And so at that point, you can go into your application, you can look at it with the Redux extension in Chrome, and you'll actually see your initial state populated, which is pretty cool. And then we can go back into our slice and start creating the reducers that we need, right? Our first one would probably be save to do. So save to do is going to take in the payload, which is basically just the new title as a string. And we're using get ID hash here, which is part of our helper files. Our very first helper is get ID hash, which is basically just very simple. There are loads of different ways of doing this. Just creates a simple ID hash for us. And then we have new to-dos, and then we save state to-dos equals new to-do up front, and then we spread our existing to-dos so that the new to-do is always at the front of the list. So we can see in our main app structure that we have to-do input right here. To-do input is where we enter our to-dos to begin with, right? So it's basically just an input and a button. We have a generic button that takes a handle click lets you know if it's disabled. That's basically all there is to it. It's pretty simple. There are some variants and other things like that, but it's not super fancy. What we're doing is we run our on change to our local state, our local use state instance of what this text is as we're entering it, right? Pretty simple. And then we have an on key down event that is looking for the enter key. If it sees the enter key, we go to save new to do, right? And if it's not a blank string, then we're going to dispatch save to do, new to do, and we're going to clear out the input. Pretty straightforward, really. We have the to-do list, which is a pretty simple component. All it's really doing is grabbing these items from our global state. So it's grabbing quite a bit. Right now, we only really care about to-dos. So it's grabbing to-dos from global state. We'll not worry about the filtering right away. It's going to map through that list of to-dos, and it's going to run through to-do display. And to-do display has a couple of different things it can return. We'll go into that in a little more detail later on. Right now, we're just going to look at the main display for to-do display. We have a complete button, we have a delete button, and we have the title display. We won't worry about tags right now. So it's basically just a really simple Flexbox layout of button, text, button. Once this is clicked, we are going to send that to handle toggle completion, which is right up here, because this is for a single to-do item. We already know what the ID is. So we're going to pass the ID to this dispatch, toggle complete to do. So let's take a look at that in the slice. Throughout the slice, you're going to see this kind of pattern where we're creating a new to-dos array. We're saving that to local storage, and then we're saving it to our global state. We save it to local storage so that we have a little bit of persistence. So save to storage and load from storage really couldn't be a whole lot simpler. They're basically just taking the data from our to-dos, and we know that they're of type to-do, and then we're just going to stringify that and store it to local storage. Really simple. When we read it out, we're going to throw that into a try-catch block because we can't trust that to be parsable. We could use IndexedDB or SQLite or something like that, or we could save to an external database if we wanted to. This is really simple, and for an application like this, this is something I'm going to use, so I don't mind this. This is pretty cool. And we have toggle complete to do, and then handle delete to do, the same thing, right? Whereas the delete to do reducer here takes in the string ID, and it says basically filter out anything that doesn't match that ID. Where it gets interesting is when you'll see that we have two different versions of this. We have this version that gets rendered out, which is the typical to-do list item. And then we have this one when it's in editing mode. How do we get into editing mode? Well, this to-do title component, when this is clicked on, it triggers this function handle select for editing, which dispatches this ID to a reducer on this slice. And it does a couple of things in state. One is it sets the selected to-do ID to the one that we were selecting, but it also puts us into title editing mode. And so when it's doing that, and we go back to to-do display, now you can see that we would actually, instead of displaying this, we would render out this instead, which shows the input. Title input is very similar. We have an OK, we have a cancel. That all does what we would expect it to do. We're also listening for key down for both enter and escape. So if I'm editing the title and I hit escape, it's going to automatically cancel out of that mode for us using those same stuff. So this is basically just going to undo some of what we just did. So it's going to say, are we editing the title? No. And then what's the selected to-do ID? A blank string, right? So that gets us out of that mode. And then if we indeed save it, then it goes back to handle save edited title. which is right here. So we not only set title edit complete, but we also update the title in a very similar pattern to what we showed you before, where we're mapping through those items and saying, oh, if the ID matches, let's pass in a different title value based on what we did. Now this one we pass in a to-do action by ID object as our payload instead of just a string, right? So some of them are like that, but most of them are just strings. So it's pretty easy. So if you're a little intimidated by TypeScript, you really don't need to be, because it's not that bad. There are times when with TypeScript, you'll get errors that don't make sense, but the more you work with TypeScript, those errors will make more sense, like type of never, stuff like that will come up. And once you've worked with it for a little bit, those will become really clear what that means. And once you have that stuff, and then again, save to storage, we'll save that stuff to storage, and then we're going to use that load from storage up here in the initial state, right? And so once you do that, then you can refresh the page and your to-dos will still be there. As long as you don't clear out the storage in the browser and you're on the same browser, then it'll be there. So at this point, we can create a to-do, we can edit the title, we can set it to completed, and we can delete it. So we have those basic, for lack of a better term, CRUD features that we wanted. So let's take a look at filtering. So filtering is based on the tags for the items. So let's take a look at our data definition again. So the tags are down here, and it's an array of strings. So each to-do has an array of strings, and we can see in our to-do display that the tags are down here. So we have two items that are significant. One is this button add tag, which is just like an SVG icon of a price tag with a plus on it. We have the ID of this item. This is going to open up a modal that will have various tags you can choose and an input that you can type in new tags, right? But before we do that, we need to make sure that when you click on it, it registers which to-do ID we're talking about. We're going to use that same selected ID. And then we're going to map through our tags with a custom tag thing. It's basically just a chip is really all it is. But it has a close button on it that can be used to delete the tags. We have this button add tag. So right up here, button add tag, again, is just this icon with a tag. And this prop that says add, I built it so that we could pass this in to display the plus sign or not, right? To make that a little flexible. That's one of the things that's really nice about using SVG graphics is you could basically very easily turn them into JSX and turn them into components where you can play with animations, things like that, within the SVG, because the SVG essentially is just markup, right? So it's super easy. This is just a button. All it does is dispatch this when you click on it. So set tag modal open. It's going to use that same selected to-do ID that we used before, and it's going to make sure that it's set to open this modal. I've got a generic modal that I made here that we're using a couple different times. So this is a really simple Tailwind modal with a close button. We pass in the handle close. We pass in the title, and it is open. When we click this button add tag, it sets that, is the tag modal open. So we're using this selector, and selector is getting us some information from global state, including is the tag modal open, right? So we're going to use that to make sure that the modal knows if this is actually open. And this component has an input for entering custom tags, as well as an OK there. And we also have a list of the existing tags that if you click on it, then they'll be automatically added to the to-do, right? And we have some functions here that are what you would expect to see, right? So if you click on a tag, it's going to dispatch add tag, and it's going to close the modal. If you click OK on the input button here. If you click on this button, it will add the tag and close the modal, right? This updates the local use state for the tag input. And then we're listening for, we have an on key down that looks for the enter key. And if it hits the enter, just like we see before, it's the same as hitting the OK. As long as the OK is enabled, and we have that set, if the tag input is nothing, then you can't click OK, right? That just makes sense. For the filter selector is enabled when you're in the footer and you click on the filter button, it pops this thing up. And so again, it's based on that same modal that we made before. And it's looking for, is filter modal open, right? And we have tag filter, hide completed. These are all things we need for this particular modal. This modal is going to allow you to hide all of the completed items. So if you do that, then we are going to do set hide completed in our slice. Same idea. You're getting the idea, right? So we set hide completed in global state. Now we can go back and look at our filters, right? That we were ignoring before. If hide completed is enabled, and we can see that in our selector from global state, if it's set and is complete is false, or if hide complete is not set, then we let it go through. Same thing with tag filter, if nothing is set, or if tag filter is set and it's included in our set of tags. Pretty straightforward, just two simple things. And again, a lot of this stuff could just be moved off to a helper file to make this cleaner, but that's basically how that works. Now that we have the filtering working, we can get to dark mode. Our dark mode slice is very simple compared to the other slice that we're looking at if we compare the two, right? So just in terms of the length of it, there's a lot more going on here than there is here, because we really only have one item in our state. So dark mode state is a Boolean. Now we could put this all in the same slice if we wanted to, but I wanted to have two separate slices because dark mode is completely separate from our to-do items. There's really nothing that depends on anything else there. In our Redux configuration, we combine these two things together, right? So we get initial dark mode, that's here. It comes from our helpers file, and get initial dark mode is down here. So it's going to check the browser to see what it prefers. If it prefers dark mode, it's going to check local storage. If it doesn't find any dark mode preference in local storage, it would return the browser preference. So local storage will always supersede the browser preference. So it gets that as its initial state. We call this part of our state, our slice, we call it dark mode. And then our initial state is what we just created. Our only reducer is set dark mode, right? So it takes a payload of a string. If that payload is equal to dark, then we'll set the dark mode. And we use this process dark mode function in our helpers. So process dark mode change. We're going to save that to local storage so that when we restart the page, we refresh the page, it's going to know what our preference is. We're also using this set dark mode class. Set dark mode class is going to add dark as a class to the very base of our page at the HTML element, right? So once we have all this set, we actually don't have dark mode enabled yet. We have to go back into our Tailwind config and add this line. Now, you may be eagle-eyed and you may have seen this when we looked at this before, but basically dark mode class, this is all we need. And once we have that, we can go into our other components and start adding these classes with the dark prefix. Once we do that, then when we toggle back and forth, you can see dark mode being darker than this. Once you have all that set up, you can toggle back and forth and see it working. This is the selector that you'd use when you toggle that back and forth, right? So we have an icon for the sun. We have an icon for the moon. I've grown to really like Inkscape. I'm using it more than Illustrator now because it thinks in SVG really well. So I can take stuff out of Inkscape, throw it through a tool called SVG to JSX, and basically I've got a component. It's very, very cool. So these two I just made by hand in Inkscape. And we have a little circle back here, and the color is primary, which in our case is orange, but we can make it whatever color we want. It's one of the nice things about having these declared colors is we can just change primary and secondary to whatever we want, and we have a whole different look. And we don't have to change it in 100 different places. We just change it one place. We have transitions set, so each icon becomes less opaque when it's not selected, that kind of thing. So if you click on this, it's going to dispatch the set dark mode, right? So we're passing very few props, right? So to-do list is probably the only place we're really passing a lot of props, and that seems appropriate, right? But that's basically it for the layout and build out of the application and all of its features. When it comes to testing in the Redux world, one piece of advice that I got, I think it was on Reddit somewhere, folks were talking about testing not with a mock store, but with their real store. And that I thought was pretty interesting. And in fact, that approach made testing pretty easy. So in this case, we are doing a simple integration test with our app component. We're going to wrap the provider around there and use our actual store. So we can dispatch a save to do with a test title, and then we can expect that to-do list to be in the document. Now, before we run that dispatch, it won't be in the document because it's not going to display the list of it if there are no items, right? So the other tests are a little more complex, where we actually do a click sequence. I'm using React Test Library, and I've really grown to like it. I used Enzyme for a really long time, and I'm sort of slowly moving over to using React Test Library. And one of the things I really like about it is it makes doing click sequences like this pretty easy. So in this case, we're using some asynchronous functions like act and wait for to create, in this case, just a dispatch, but we could also do a fire event like a click. And then we can see those changes in our store, right? So we're going to say, in this case, it's state after complete click, we can expect that complete would be true for this item, right? Pretty simple test, but there's a lot more we could do with that if we wanted to. But you can see that we're kind of starting from a blank slate, and we create our test state. What we could do with tags, in this case, we're mocking some of our helper functions. We're requiring actual for all the other helpers, and then we're replacing the ones that we want to mess with. So the functions that we use to get our initial state, the load from storage and get tag filter default, we can use this approach to set up our initial state for our various test conditions. So in this case, we have tags, we identify the delete button, we expect the tag to be there because we haven't clicked it yet. Then we click it and we expect that to do tag to not be in there anymore. Many of the functions that we're using here, because we're not passing in data with props, we're having to wrap a lot of them with the provider to make sure that we're getting what we want, and that we're testing all the various pieces. And within, a few hours, I was able to get 100% test coverage on all of these TypeScript components and the helper files with those techniques. So there's no reason to be intimidated by our old pals TypeScript and Redux. I think of TypeScript like a gruff English teacher, a stickler for commas and whatnot, but in the end, you grow to respect them because the feedback you got from them made you better at commas and whatnot. I think of Redux like Sloth from the Goonies. He could seem scary at first, but especially with his friend Redux Toolkit, he's kind of a sweetheart. Plus, it's nice to have a strong friend around who can rip iron chains off of a wall to bring you slices of state or baby Ruth bar. I hope you found this helpful, and I hope this prepares you, at least in some small part, to make something interesting on your own. Go ahead and clone this project and use it as a reference if you want. There'll be a link in the description. So we extended the typical to-do app but there are loads of other cool things we could do. What do you want to see? Do you want to see me connect it up to Firebase, or a serverless API using a Lambda, or a feature to set the order of the to-dos with drag and drop? Well, let me know in the comments. Anyway, that's all I've got. Bye.